So let's begin with a definition, and then we'll talk a little bit about what that definition actually means. So we have the absolute value of a real number, so written with those two vertical bars around it, so it's the absolute value of x, is the non-negative value of x, and sometimes also thought of as the distance from 0. So we have this piecewise function written down here, and we're certainly going to look at piecewise functions in more detail in the coming lessons. So the absolute value of x is equal to x if x is a positive number or 0. And if x is a negative number, it's equal to negative x. So all that means is that when we apply the absolute value to a number, what we end up with must always be positive. So let's just take a look at some of these expressions down here. So the first one, absolute value of 6. So the absolute value expression ensures that whatever we're taking the absolute value of becomes positive. So the absolute value of 6 is equal to 6. The absolute value of 8 is equal to 8. Now look at this next one. We have negative the absolute value of 5. So these absolute value signs are kind of treated like brackets. So you're going to apply the absolute value first, and then look at the other operations that are occurring. In this case, the absolute value of 5 is 5, and then we're going to negate our answer, which gives us negative 5. So please note the difference here between our first and third example. In our first example, it was the absolute value of negative 6. The negative was inside the absolute value bars, so that expression became positive. In our third example, the negative sign was outside of the absolute value bars, so it was unaffected by it, so our end answer was a negative 5. Continuing on to our fourth expression, so the absolute value of negative 3 is 3, plus the absolute value of negative 7 is 7, and 3 plus 7 gives us 10. So note that, similar to the third example, we evaluate these absolute value expressions first, and then we use order of operations after that. Our fifth expression, negative 2 times the absolute value of 4 minus 1. So again, we're going to treat it as if there are brackets here. You don't actually have to put those brackets when you're working through it, but that's conceptually what's happening. So negative 2 times the absolute value of 4 minus 1. So if we do that expression inside of the absolute value, that's 3. So it's negative 2 times the absolute value of 3. That's the same thing as negative 2 times a positive 3. Our end result, negative 6. And our last expression. So we have a lot of different operations happening here. We have a lot of different absolute value signs as well. So let's use our order of operations to tackle this problem. So first, 2 minus 4 times the absolute value of, so we have 3 minus 7. That gives us a negative 4. Minus, now we're going to do the stuff inside this absolute value bars first, but even inside those absolute value bars, we have this expression that's in brackets, so we're going to have to do that first. So negative 2 squared, negative 2 times a negative 2, that's equal to a positive 4. So here's what we have so far. So let's simplify this a little further. 2 minus 4 times the absolute value of negative 4. So the absolute value of negative 4 would be a positive 4. So the absolute value of this expression has to be positive. Minus the absolute value of negative 4 again. So the absolute value of this expression is going to give us a positive value. So that's 4. And at this point, this is an expression that no longer has any absolute value signs. So we can just treat it using our order of operations. So we have 2. We'll do our multiplication first. So 4 times 4 is 16. So 2 minus 16 minus 4. This is going to give us a negative 18 as our final answer. So just note as we were working through this that we did the operations inside the absolute value bars first. In some instances, we had to further do other operations first, so we just use the order of operations within those absolute value bars, and we just eventually simplify those absolute value expressions and then get an answer for our final expression. All right, question 2. So the volatility of a stock market is the average amount of change to the stock prices in that market, regardless of whether they're positive or negative. So if a stock increases in value, that adds to the volatility of a market. If a stock decreases in value, that adds to the volatility of a market as well. So regardless of whether it goes up or down, we treat those as volatility. It doesn't matter what direction it goes into. So I will kind of state before we go any further, this isn't strictly how volatility is calculated for a large stock market, but this is the idea, and we're going to use absolute value expressions to help us out here. So stock A increases from $100 to $110. Stock B decreased from $80 to $60. And stock C increases from $210 to $225. We want to write an equation to calculate the volatility of this stock market. So our volatility is going to be the average amount of change. We have 3 different stocks here. So we're going to take whatever our answer is and divide it by 3 to get the average. Now for stock A, it increases from 110 to 111. So we're going to look at the difference in value by taking the new value, subtracting the old value, and taking the absolute value of that expression. So that's stock A. Stock B decreased from $80 to $60, so it ended up at 60. And it started at 80. And stock C increased from 210 to 225, so it ends up at 225, but it started at 210. So there's the amount of change in each one of those stocks. So now let's evaluate what the volatility of this market is. So 110 minus 100, this is the absolute value of 10. 60 minus 80, this is the absolute value of negative 20. And 225 minus 210, this is the absolute value of 15. And of course we want the average of those things. So the absolute value of 10 is just 10. The absolute value of negative 20 is 20. And the absolute value of 15 is 15. So our volatility would be the sum of those 3 values divided by 3. So the volatility of this market is 15. So that's the average change, regardless of whether it was a positive or a negative change. I will say again, this isn't strictly how volatility is calculated for a stock market, but this is the idea of what volatility is in a stock market. It's the amount of change that's occurring, regardless of whether that's positive or negative change, and it's referred to with a positive value. Now, you perhaps might look at this and say, well, I could have just reasoned that this first difference was 10, and this second difference was 20, and this third difference was 15, so why do I have to bother writing all of these absolute value signs when I can just kind of see that? Well, okay, you can look at it and see it, but realize that when these calculations are happening in the real world, they're happening due to computer programs. And computer programs need an unambiguous way an unambiguous algorithm, to be precise, that will allow them to calculate all of these differences and achieve a positive value. And I will tell you, as a computer programmer myself, that the easiest way to do this sort of thing is by telling the computer to take the absolute value of these things, and that way you tell it, find the difference in these two, and take the absolute value to end up with a positive value. So that's a little bit of how they're used in the real world. That's why they would apply to a problem like this. And that's your introduction to absolute values.